if you click this button, and then now if you go over to the data, so not only those value, right, pixel coordinates and intensity, also you can read the new coordinates. The two sets of new coordinates are displayed here for the 2D powder samples, maybe also 3D powder samples. Here, 2D powder sample means has a fiber symmetry. The symmetry axis is z-axis. And you can see the angle coordinates as well as qy and qz. For the 3D powder system, we use the polar coordinates. So radial direction is q, and also the phi angle. Phi angle starting from that axis, so horizon, and increasing as you go anti-clockwise, like this. Okay, not only that, so the other option is available is if you go here, maybe you can use the SAXS tool, for example. So click the SAXS tool. Okay, these are the tools for averaging, azimuthally averaging the data. There are some parameters you have to put it in, punch in. Let's just say the most important part is generating the Q map, right? So based on these parameters, we can calculate a Q value for each individual pixels. Okay. In order to do that, well, there's two options I provided. So one is the pixel based and there's a Q based. Well, I guess for now it's not important. So let's pick the pixel base, and by clicking this button, it will generate the Q map. See, Q map and theta maps are generated. And next step is, so what does mean is we map the entire image, Q space of the entire image, and then also azimuthal angle, theta, right? We generated. So once this is ready, we can average the data, okay? Typically CCD images or any type of the SAXS data, you want to define the lower limit of the intensity and upper limit of the intensity. Particularly for the Pilatus detector, there cannot be negative intensity. So lower limit will be 0. So intensity below 0, we don't count. We neglect when we do the integration. Also, above this value, okay, we neglect. But we know the Pilatus detector maximum count can be 2 million. So we can put 2 million here. Okay, and if you have already generated mask, you can load the mask by clicking load. Yes, for this, I will just load the standard mask. Okay, and probably for particular this image, I may have to mask this region out and then also the beam stop out. But for just a demonstration, I will use those simple mask. Okay. Okay, pretty much ready to go. Other things we had to do is directory for average the data. So where we want to save the average the data, okay? Because that's the SAXS data, okay? SAXS data, the average the data will be saved under the SAXS directory. But if you want, you can specify the also the particular directory instead of standard average directory. So let's just say ABG, AB2, okay? So then the software will generate a directory called subdirectory called AB2 under SAXS. Okay. I think it's ready to go. And click this button, average data on SAXS image viewer. So if you click this button, the azimuthal average will be performed on the data that is displayed here. Okay, so click. It may take some time. Okay, so this is average the data. If you want to plot the data in the log scale, you can change like that too, right? Okay. So this average data, it is already saved. If you go SAXS, and then you see the AV2 directory is generated, right? So go there, and then this is the average data. Okay, this is a text file. You can open with any text editor, like this. Okay, good. Other thing is you can do the even sector averaging. For example, I want to average the along that direction and then maybe that direction, right? Because intensity is not homogeneously distributed. So let's just say I want to average it from 5 degree to maybe 15 degree. Well, if I click this one and then go over, I can read the 5 value. It's a 17.6 to maybe 57. Okay, 17.6 to 57. Show me the angles. So those will be, okay, starting angle and perform the average. So now it's averaging it down, right? And this data is saved as the file name is the same up to that far. Name is from the image name, and then it add the dash azim underscore starting angle and then end angle like this. Okay, so that way we can avoid the data overwriting. Okay, so that's about it for the simple data averaging. And instead of average the entire, the section or the images, Azimthal averaging, you also can do line cut as well. Okay. Well, if we want to erase these lines, you click this button, eraser, then it will go away. There's option like line cut here. Okay. Uh, there are many things here, but mostly for the GSAX. So these two option is for the SAXS transmission SAXS data. Okay. So what it does is for this one, you can do the phi cut, so along the azimuthal direction. Okay. And the next one is you can make a Q cut along at that phi angle, right? Like this. For instance, let's use this one, okay? So click this one and then let's say I want to make a line cut at Q equals 0.94, okay? Turn it off. 0.094, okay? And do it. So then it will display the trace that I made. Okay. So these are the intensity along this line. Um, well, here the phi angle is actually not starting from here. It actually started from on the other side. Okay, so it starts from here and then going anti-clockwise. So direction is the same, but only the difference is angle difference is like a 2 phi. No, actually, a pi, 180 degree is off. But other than that, there's the same. Okay, and then if you want to make a radial direction cut, so let's just say I want to make a line cut along the 45 degree. Here's 45, okay, and then click on it. So then it will do the line cut along the 45 degree. You also can plot this data in the log scale, okay? And if you want to you can plot it on the different figure. So this is figure number 1, as you see here, figure number 1. So when you do the line cut, let's just say now you want to do the 46 degree, okay? And then you want to plot it in the figure 2, like this, do it. So then the figure 2 is generated. Okay. Okay. Or if you keep this one as a figure number one, then it will overwrite, not overwrite. It will add the data to the existing one like this. Okay. Um, that's this is it for the data line cuts and averaging.